Today we're going to take a look at some of the maths modules in AI and see how they can be used to vary controls or values within the salvation system. Okay, so first of all let's give ourselves a nice little test rig. So I'm going to add my rectangle, so it's generator rectangle, and a window so that we've got a complete OpenGL chain. Let's connect those together. Let's turn the window on. Now what I'm also going to use here, as well as the math modules, I'm going to use a module that will allow us to look at the value that's coming from our maths module. So I'm going to go right click, insert module, controller. The controller section is really useful when you're dealing with any kind of value. It gives you different ways to work with those values. We're going to choose monitor. Let's just put the monitor in line. And then we should see our value being shown on this monitor whilst we're working with our numbers. So let's just do some basic things first. We'll look at the basic math modules. Then I'll give you a quick introduction to the formula module and the vector formula module and show you some of the possibilities that we've got with those systems. So we have a math section. Now I'm just going to cover the basic ones at the moment. Let's just have a look at things like vector math. So vector math is the most basic of math modules. I'm also going to add two text boxes. So that's controller constant. Then right click on the constant and load alternate skin and choose text. I'm going to copy and paste that so I've got two, one for each input. And then we'll take the output of the vector math module and connect it to the monitor. Okay, so we can see at the moment that it's set up to do a very, very basic sum here. It's set to addition, and it's adding 0 to 0 at the moment, and so obviously we're seeing a 0 there. So just to confirm, if I add this, and if I make this a 1, we'll see 1 in our box there, because 1 plus 0 is 1. And if we change that to a 1, we'll see 2 on our monitor here, because 1 plus 1 is 2. Okay, so on the drop-down box on the math module, it offers us quite a few different functions there. Some may be familiar, some less so. So starting from the top, addition, subtraction, multiplication, division. Then we start to get onto some more interesting maths ones like modulus. We can set values. Is equal to, it is, that's a logical assignment rather than is equal to. Is less than or equal to, is greater than or equal to, or is not equal to. That's a useful one, the exclamation mark, is not equal, does not equal. Or we can put a range, or we can have a ceiling, and we can have minimum and maximum values. So for instance, let's just do 1 multiplied by 4. That's going to give us 4, quite obviously. So the vector math module is really nice and simple, but it's very useful for a lot of the calculations that you need to do. Now if we have a further look in that math section, we have a slightly more advanced module here called formula. Now the vector formula, that will actually work with both vectors and non-vectors. But for the formula, we've got a specific one for formula and one for vector formula. So I'm just going to load the formula one for now. Now the formula module is a slightly more complex module than our math module. It has a lot more functionality. So I'm going to connect that in line again. Let's just go for 1 and 2. What I'm going to do, I'm going to just add some more number boxes. You can see we've got 4 inputs on this formula module. And so what we can do here is we can actually refer to these inputs by their letters A, B, C and D. And so we can create equations and algebra within the module. So for instance, I can say A plus B. So if we look at what A plus B is, we've got A is 1, B is 2. So when I press enter and compile, we'll see the value 3 there. So that makes sense, doesn't it? So A plus B equals 3. So if we did B times C, 2 times 3, we should see 6. So let's try B multiplied by C, press enter, press compile, and we get that 6 there. Okay, so this is all making sense so far. Now we can take this slightly further. We can use brackets in our equations. So let's say bracket A plus B, bracket. Now anything that we put inside of a bracket will be processed as a whole calculation, and then anything external, any sum applied to the contents of the brackets, will be applied to the result of the contents of the brackets rather than the individual numbers. So for instance, we've got A plus B times C. So that's 1 plus 2 equals 3, multiply by 3. So we should be seeing a 9 on our monitor. So I'm going to press enter, press compile, and we get that 9 there. Okay, so hopefully you're keeping up here. This is starting to make sense. Now, just to confirm, if I take my brackets out, I press enter and then compile, we see a different value there, and that's because we haven't got the brackets there. So we're not saying that A has to be added to B before they're multiplied by C. We're saying do this as a linear calculation. So you can see how brackets can affect your inputs there. We could take that further and we could have multiple bracketed statements. So we could have, let's say, A plus B times C plus D. So A plus B is 1 plus 2, so that makes 3. C plus D is 3 plus 4, so that is 7. So 3 7s are 21, so if we press enter, compile, we get 21 there. Okay, so hopefully this is really starting to make a lot of sense now. Now, there are a lot more functions that this module can work with. So I think what I should do is I should show you the library, the maths library that we're based upon, and it can give you an idea of some of the functions that you can use. So I've actually brought the page up on the internet here. There we go. So mu parser, this is the library that we're based on. Now if you search for mu parser, you'll find this page. Just Google mu parser. And on this page, if you come to built-in functions, this will show you some of the things that you can actually type in. So you can see that by default it can do a lot of trigonometry and stuff like that for us, different types of logarithmic calculations. It can do square rooting work for us. We can add things together, round to nearest integers. We've also got a lot of other operators. So when we say assignment, so if I say A equals B, what I'm saying there is A is the value that I have set for B. So if I said A equals 1, then A would be a value of 1. Things like logical and, logical or, greater, equal, not equal, all these kind of things, powers, divisions. Now down the bottom there's a really useful one here, if, then, else. So I'm actually going to show you how this one works, because I think it's a really, really useful component to make use of. So what we're going to do, we're going to come up with a statement. We're going to say if A is greater than B, then show us value C, but if it's not greater than B, show us value D. And just to make it obvious there, so if it's greater than B, we're going to get a 10, and if it's less than B, we're going to get a 1. What I'll do here, in fact, I'm going to add a notepad, and I'm going to just type down what we're actually going to try and achieve here. So I'm saying that if A is less than B, then give me 10. Otherwise, if A is greater than B, give me 1. So this is what I'm saying here. This is what I'm going to put in my mathematical form. An if, then, else. So if, then, otherwise, that should say else. So if this statement is true, then give me this, else give me this. Okay, so let's see how we actually implement that in coding form. And it's actually really quite simple. So first of all, we want our qualification statement. If A is less than B. So we're going to say bracket, if A is less than B. Now the symbol that we use for then is the question mark. So then we're going to put in our value. So here we said a value of 10. And our symbol for else is the colon, followed by the value that we want to give if we're going for our else result. So I'm going to press enter there. I'm going to compile my formula. Now, if A is less than B, so because A is currently less than B, I'm hoping that when I press compile, we're going to see the value 10 here, which we are. And now if I actually adjust this so that it's greater than 2, we can see that it's going to give me the value of 1. So that's a really useful statement. Now, just to show you sort of how real-time this can be, if I was to put an LFO into this, and we've given the LFO a range of 0 to 2, so half the time it's going to be below 3. So half the time it's going to be below this value and half the time it's going to be above this value, and we should see in real time this value here changing. I'm just going to slow it down a little bit. We plug that in, so we've got a 10, 1, 10, 1, and that's as that value is varying within that range. So these are real-time, these formula editors, so they're really, really powerful, really, really powerful. As I said, I would urge you to have a really good look at the MuParser page. So that was MuParser, M-U-P-A-R-S-E-R, and you can use these as reference quite a lot. It's really, really useful. So yeah, using the maths modules in AI will give you a huge amount of control over your values and allow you to do really quite interesting, interactive, real-time reactive things.